I just finished uploading my previous video where I rebuilt my clock circuit, and I'm moving immediately right into the reset, not even delaying a little bit. So the purpose today is to get into the reset circuit and set it up such that on power on or on reset, I make sure that I have the circuit completely in a known reset state so that I can move forward. Make sure that all my tests end up clean. Let's get right into that. Hi, my name is Adam. I'm building a 16-bit computer from scratch. I hope you'll join me on this journey. Okay, here's where I left off with the clock circuit about 2 hours ago my time. And my intent is to build the reset circuit up here. Now I've been doing a little bit of thinking about what that might look like, and this is what I've come up with. Now, bear with me, it's overly simplified at this point, and I'm gonna run into a few things, some things I know about, some things I don't yet. One of which is going to be the clock and how I'm going to drive the clock into here. This is my 3470 power supervisor, which I had on the previous circuit. I have since pulled that, and it is sitting here, and I need to integrate that into my reset circuit now. Now this reset signal is an open collector, which means that there is no high signal that comes out of it. Its purpose is to expose ground to whatever is hooked up to it. That's why it shows as an active low. So when the system is in reset, the signal or whatever's plugged into that is pulled low. But when it is not in reset, it's as if it's completely disconnected from that particular line. I also want to have a button that is going to do the same thing, and I'm basically going to tie one end low. And when the button is not pushed, it's as if the button is completely disconnected from the system. That connection doesn't exist. But when I push the momentary push button, it will connect that signal to ground, and so I can manually affect a reset as well. Both of those signals are going to be fed into an SR latch such that when the reset is triggered, it's an active low signal, we're going to set this, and then being set, clear is going to be pulled high. That will end up clearing out all the registers. And then I've got a 74LS or HC, depending on if I'm doing the breadboard or the PCB version, which will count down until it reaches 0, at which point the borrow is going to go low, and that borrow is connected to the reset of the run, which will reduce this clear here. Now the reset is also fed into the parallel load such that when the reset itself is low, so I'm actively pushing the button, or the reset hasn't timed out on the 3470 yet, this is going to be loading whatever value I have programmed into this. And on this piece of paper I have 4 clock cycles, but for testing purposes I plan on using a 4-pin dip. So let's start pulling this together and put it on the breadboard. One side of this IC has 3 pins, the other has 2 pins, and I believe you can just catch that in the camera. 3 pins on that side, 2 pins on this side. And so I'm going to drop this in here. Nope, I'm going to drop it in more over here. And then I want to hook this up. So these 2 pins get hooked together and are tied to, actually I'm going to go this way, to 5 volts. Pin number 2 here is tied to ground. Pin number 1 is the timeout delay, and I've got a 0.01 microfarad capacitor, and that's going to set the time duration that the reset signal is pulled low once power has been brought to the proper state. And then the last thing I want to do is I actually want to bring out this reset signal and hook it up to an LED. So now when power is applied, this light should stay lit for a short period of time, and that's exactly what I want to see on reset. Now the other one is going to be a real easy hook up here as well. One side is going to go to ground. The other side is going to basically be hooked up to this reset circuit. So I should be able to push the button as well in order to generate the reset. That's relatively trivial at this point. Let me spend a minute and get these wires cleaned up. Okay, next up I need a set reset latch. That's going to look very similar to what I've done here. And as a matter of fact, I'm going to use the same IC because I've got room for another latch here. Now, the set and the set reset is going to be driven off of this signal here. And so what I want to do is I want to pull, oh, that's an active high now, or I can take it to the low side. Okay, so I can get into reset state here on the set reset latch, but there's nothing to bring me out of that reset. For that, I'm going to bring in a 74LS193 IC, and this is the up-down counter. And I've got a general idea of how I want to hook that up. So let me get that wired up according to this plan. So let me get the basic wiring done before I hook up the reset and the run mode components. Now this borrow out here is intended to be hooked up to the reset input down here, such that when this goes low, it resets. And then the reset is also intended to come from here and hook into this parallel load signal here. Finally, the clock. I do have this higher speed clock here, which I am going to use to drive the reset circuit. So that should be there. And so when I push the button, it comes out of reset quite quickly. If I put this into run mode and I hooked up, say, down here, it takes several clock cycles for it to extinguish. That's exactly what I wanted. But I like the faster reset. And so when it powers up, it goes straight into reset and gets ready to go. The last thing I think I want to do is I want to use the reset here to put the circuit into run mode. So it should automatically put it into run mode on power up and on reset. I may regret that. Okay, let me do some cleanup here, and then I'm going to leave the 4 lines that I'm going to end up pulling out to these dip switches so that I can set how long the delay is for reset, how many clock cycles it takes. Okay, something's wrong there. That should not be resetting. Okay, I'm not sure if this shows up on camera at this point, but when I go into run mode, the reset is happening. I'm getting a flash on the LED, and I'm not sure if the frame rate is picking that up or not. So I'm trying to troubleshoot that and debug that, figure out what's going on there. I'm not exactly certain what the root is for that yet. So that's happening when, so that's bringing that low. That's not the way that should be happening. All right. Kind of makes me wonder if this IC isn't bad because nothing else is hooked up to trigger that. Let me just try another one. That's what I would expect. What the hell? Did I just cook it? Output of one, input of the other. Output of one, input of the other. That's accurate. That's probably my problem. Okay, I think I've got this figured out. I hope I do. And let's see here. Let's get all of this tied back together again. I don't believe that. Yeah, that's incorrect there. Now I had that signal here tied here. Okay, I did say I was going to regret that decision to have it set the mode properly. All right, after all that mess, I owe you a better explanation of what this problem was. And actually, there were several. The first problem was when I pressed the reset button, I wanted it to set this into run mode, which it would. And then, of course, set the latch here, the set reset latch at this point to be in reset. The problem is that when I press this button, it would tie that same signal low as if I was pressing the reset button up here. So I'm not able to directly set this mode without something else going on. So I'm going to think about that and see if I can actually do that. That was problem number one. Problem number two was I had a bad NAND gate, and I replaced the NAND gate, and it worked for a moment, and then it stopped working. And the reason I had a bad NAND gate here was because I had this set up so that the LED was an active low LED, and I did not have a large enough resistor in here. As I'm touching it, I didn't have a large enough resistor in here to limit the current that was going to be synced, to limit the current that this NAND IC was going to have to sync. And it was more current than it was designed to handle. So inevitably, I ended up cooking a couple of 74LS00 NAND gates. I'll add those on to my next order at some point. Problem number three then was making sure that this was an active high signal so that I was driving current out of the NAND gate rather than sinking current through the NAND gate. And so I did move that signal from here to up here to make it an active high up here rather than an active low. Again, I'm learning. I've got a couple more things I want to do to tidy this circuit up. This reset signal, which comes off power supervisor and comes off this momentary switch here, that signal is actually floating unless it's pulled low. And so in order to overcome that, the LS logic has internal pull-up resistors in order to make sure that that signal is pulled high, but the HC logic does not. And if you leave something like that floating, it can have some really dramatic effects on your circuit. So this input right in here where this upper purple trace ends is where I want to put that pull-up resistor. But I've already got a resistor here that's blocking the way, and it's just kind of tough to get in there and get that. So tracing that same node out here, I could put it here, but this capacitor is a bit of a problem. But this is connected also through here, and I believe I can fit that here. So that then gives me the pull-up resistor I need on this node in order to ensure that if the set is not actively low or specifically low, that it's actually pulled high. The next thing I want to do is I want to make a little bit of room over here because I want to also add in here a 4-pin dip. Now my 4-pin dip here is specifically for identifying what my starting point is for my countdown timer. And so what I'm going to do is I'm going to pull these over to the dip. I'm going to pull them low with a 1000 ohm resistor. And so each one of these will then have a resistor in here, and I'll have to go about cleaning them up a little bit. But you get the idea here as I get that cleaned up. Well, my phone started going nuts, and since it was vibrating, it wouldn't record anything very cleanly. I didn't want to make anybody motion sick. What I've done is I've tied the other side of that dip switch to 5 volts, such that when the switch is on, it overrides the pull down resistor and provides 5 volts to set the countdown timer. So it's driven from the dip switches rather than hardwired to ground or 5 volts. So let me get this organized properly, and then I'll be back to figure out how to integrate this into the circuit. Okay, the last thing to clean up here is the reset pin, the run pin, the run LED, the reset LED, and the actual output clock. I don't know that I'm going to need this one here. I don't know that this adds any value. Okay, I think that cleans everything up nicely. Let me get the build up. Okay, currently my clock module is this breadboard right here. And other than the power connections, it should be relatively easy to extract. So this one I'm disconnecting here is my memory, which is not robust at all. This signal here is clock, and this is also clock here. So let me move this up to that spot. This becomes my only clock connection that I have to deal with. I believe I'm free here. I'm going to set the memory up here and make an effort to get power and ground reconnected. So let's see what happens when I apply power now. And I'm shorted somewhere. Now, I believe I am shorted. I am not shorted. Okay, well, whatever I did, it managed to clean itself up. It did reset. I have a loose connection somewhere. And now I've got a power problem. So let's start with, will this thing actually run? No, because I didn't hook up the clock. And now I've got power problems. I have no LEDs on here, so I cannot tell if this is powered or not. Okay, that looks like it's working. That's good. So now the next thing I need to do is I need to bring this reset line from here, which is pulled low, push the button, it goes high. So that should be that signal there. Now the last thing that I think I need to do here is when I hit the reset button, I actually want everything to clock. For that to work, I believe I need to tie this. That's the wrong clock. It's this one that I want. Okay, so that's the set reset for the reset circuit. So I believe I want to take this pin, and that's on the 74 LS151. Yeah, that's the one. So what I want to do is I actually want to take input C here, and I want to tie it also to the reset. So if this is also tied to reset, what that then gives me is the clock will come from one of these four signals. Now, right now they're all tied low. But what I want to do is I want to tie it to the high clock output here, which is the same one that's driving this counter. So I want to tie this signal to these four data inputs here. So let me pull those out, hopefully without making a complete mess of this. Okay, now with that done, those all tied to this higher speed clock, when I hit reset, everything should clock at this speed, which would clear everything out. Now what I don't have are the controls for this written yet. And somehow I'm getting an and increment there. And that's part of the no op. All right, from here, let me get into the control logic firmware and make some adjustments to the no-op instruction to latch these two. And then I'll have to figure out how I'm going to deal with that concern down here. Okay, for R1 and R2 to latch the empty value, it's a simple trivial change here to add the and latch signals to my default no-op instruction here. And I really only want those at this point to happen on the no-op. I am considering tying that to the clock directly so everything latches on every clock cycle, but I haven't convinced myself that that is the right thing to do yet. I don't have a problem with latching on the no-op because nothing should have changed and therefore nothing really should be updated, and it will be telltale if something does update that I've got something else to go and debug, so I can keep an eye out for that. So from here, it's just a matter of building the control ROM and burning them onto the ROMs themselves and getting it back into the build. Okay, I've got the control ROMs reprogrammed and replaced in the circuit. So let me apply power and let's see what happens here. R1 and R2 both cleared their contents. Program counter cleared their contents, but automatically advanced the program counter to 1, which is something that I need to take a look at. Last night, while I was staring at the circuit and unable to record because we have the house fan running and it's way too noisy to try to record my voice in those conditions, I was looking at the 74LS74. Let me bring up a pin diagram for you. On the bottom here, I have the inverted output of the variable clock here, going back to the data line. But this purple line here goes to the non-inverted output, which travels off to be selected by the 151 IC. Up here on top, I noticed that I have the inverted output going back to the data line on the 74, but I have the inverted output, not the non-inverted output, going on to the 74LS151 output. Okay, so let's change to the actual clock and try the reset again. Well, that's worked there, but I did not actually fetch the first instruction. That should be 0001 for a move into R1 based on the code that I'm running. And my latch is lit, indicating I will latch that, but it doesn't actually latch that first instruction. All right, so is it being retrieved? So these are LEDs I'm going to plug into the main bus. And then as I reset and release, the latch versus the when this light comes on. So everything's blank at this point. So does this light come on before this one goes off? I can't tell. Let me get the oscilloscope out. Channel 1, I'm going to stick on this bit because I'm interested in when that actually becomes available. And channel 2, I'm going to attach to this clock, which is really just the latch for the fetch register. So channel 1 is yellow, channel 2 is blue. And so my latch is happening prior to that. The latch here in blue is happening prior to that bit being available. So in order to fix that, I actually have to delay this signal, and this signal is driven by the clock. So that's coming literally off of here, which is being fed. I don't want to delay the entire clock, but what I do want to delay is this higher speed clock just a hair. To do that, I'm going to add a 74LS04 into this where I can actually use the 6 inverters to create a delay. I'm going to tie power up here. So does that work? That's still 0. but that now latches the 1. And this is far closer to being right on top of each other, so that the value of 1 is available on the bus just ahead of the clock here on the blue line. And I believe that solves my problem. And this is then the clock circuit. Last thing here before I wrap this video up is I've got a little bit of housekeeping to do. My 2 boards here between the memory and the new clock are not connected directly by power, so I want to correct that. Okay, next is I noticed that the memory module does not have any bulk decoupling, so I want to add that in as well. And the last thing here is a little bit of wire cleanup, but I also want to drive these LEDs not directly off the signals, but rather I want to switch them around such that they are driven by a line driver. And so let me get this rearranged here. I have 2 enable pins. I'm going to start pilfering from here. Here's an enable pin on pin 1. There's another enable pin up here on pin 19. Input A1 or input 1 is unused. Input 2 is my reset. That's going to go over to that LED. Skip 2, this goes over to the middle LED. And skip 2, oh, is that right? No, that's not right. I'm off by 1. And this goes over to the green LED. And the last thing I need to do then is tie the rest of these unused inputs low. And I'm tying these low because the HC related logic will not behave properly if they're not tied low. So I've got a little bit of cleanup to do here. Let me get the wire cleanup done and we'll come back with another quick test. Normally I would also take care of cleaning this up, but the problem I'm having at this point is this may be in place simply because I've had to do this over here. And I want to get to the bottom of this timing issue before I commit this to permanent hookups. Okay, the last thing I promised was a test of the circuit, so let me plug it in. And program counter resets properly, R1 and R2 reset properly. I've got my first instruction loaded in the fetch register properly. And it does automatically go into single step mode. And I think I like that for now. I haven't done anything to explicitly define that. It just happens to be the way that the NAND gates SR latch initialize. So I can step through this individually and it works fine. Even in single step mode, I reset, everything resets down. My first instruction is a move into R1. And so it gets moved up here to the instruction register. And this is the value that I'm going to move into R1. Sorry, R2. No, this is R1. I should know my computer better than this. And then, so it is properly doing all the instructions. The next thing I want to do is I want to point out that most instructions here are latching the register, even though that they are not actually using the register. And that was one of the things I needed to do in order to get the reset to work properly, is make sure that no op actually performed a latch. I'm not thrilled with that solution, but I don't have a better one yet. So if I happen to come up across with something, then I will look at implementing that. But for now, the software solution is going to work. The next thing here will be this EEPROM replacement. I've got to do something about getting this correct. And in particular, the diodes here are not doing what I need them to do. And, well, I guess I didn't understand my requirements well enough to pick components properly, or I didn't understand what the components properly to pick the right ones to match my requirements. I'll get into that in the next video. I am going to rebuild this, and we'll have to get to the bottom of that, make that work. So look forward to that. We'll see you soon.